You've probably used ChatGPT. You've seen it write code, summarize documents, maybe even generate business ideas. But have you ever stopped and asked, what is it actually doing? Is it thinking? Is it reasoning? Or is it just predicting the next word over and over again? Today, we're going to break this down properly. No hype, no buzzwords. And by the end of this video, we'll actually run a large language model locally on this laptop, so you can see how it really works. By definition, an LLM, large language model, is a neural network trained on massive amounts of text data to predict the next word in a sequence. An LLM is like the autocomplete on your phone, but trained on the internet and scaled to billions of parameters. At its core, an LLM is a probability machine. It doesn't know facts the way humans do. It predicts what word is statistically most likely to come next. LLMs actually work by using the concepts called as tokenization, vectors. Text is first broken into tokens, not full words, but smaller units. For example, the phrase "the cat sat on the mat" will be split into the individual words. This step is called tokenization. Tokens are not always full words. They can be full words, parts of words, or even punctuation. For example, the word unbelievable can get split into able. So the model doesn't see language the way we do. It sees tokens, chunks of text. Now, let us clarify the vector concept. Here, each token is converted into numbers. This is done because computers don't understand words. They understand numbers. For example, the token cat might become something like 0.21, 0.78, 1.34, 0.002, etc. You can say, this list of numbers is called a vector, and it's not random. It represents meaning in mathematical form. We also need to understand that the vectors for cat and dog will be closer to each other than the vectors for cat and car. Each token becomes a vector, a list of numbers. Those vectors pass through layers of a neural network called a transformer. A transformer is a type of neural network architecture specifically designed to process sequences, like sentences. Each transformer layer does two main things. First, it allows every word to look at every other word in the sentence. Second, it processes that information through a small neural network to refine the meaning. Transformers use something called attention, which allows the model to look at all words in a sentence at once and decide which ones matter most. Every token can pay attention to every other token, not just the previous word, not just the next word, all of them. Mathematically, it calculates. How important is word A when interpreting word B? It assigns weights. Higher weight is for more influence, and lower weight is for less influence. For example, let's look at a sentence that requires understanding context. The trophy didn't fit in the suitcase because it was too small. What does the word it refer to? Most people will answer the suitcase. Now change one word. The trophy didn't fit in the suitcase because it was too big. Now what does it refer to? Now it refers to the trophy. Why this is powerful? The word "it" appears near the end of the sentence. To understand it correctly, the model must look at trophy, suitcase, small or big, and understand how those concepts relate physically. Older sequential models struggled because they processed text left to right and forgot earlier context. How transformers solve this is because a transformer does something different. When processing the word, it doesn't just look at the previous word. It looks at every word in the sentence at once. Then it calculates attention scores. How related is it to trophy? How related is it to suitcase? When a sentence says too small, the model learns that suitcases being small prevents trophies from fitting. When a sentence says too big, the model learns that trophies being big prevents fitting. Let us now discuss about the different type of LLMs. There are two types of LLMs. One is cloud LLMs, and the other one is the local LLMs. Let's find out about these in more detail. Let's start with cloud LLMs, because this is what most people use. When you use ChatGPT in your browser, the model is not running on your computer. Instead, your request travels through the internet to powerful servers located in data centers. These servers contain extremely powerful GPUs that run the AI model. Your workflow looks something like this. Your computer sends a request to the cloud. The AI model processes it. The result comes back to you. The actual computation happens on machines with hardware, like advanced AI GPUs. That's why you can run powerful AI models even on a normal laptop. Your device is basically just sending a request and displaying the result. Now let's talk about local LLMs. A local LLM means the AI model runs directly on your own computer. Instead of sending your prompt to a remote server, everything happens locally. Your computer downloads the model and performs the computation itself. This means your hardware needs to be strong enough to handle it. Local models usually require large amounts of RAM, powerful CPUs, and often dedicated GPUs. Now let's discuss the hardware requirements of the cloud versus local LLMs. Hardware requirements do not matter for the cloud-based LLMs since the heavy compute happens in the data centers. So these can be accessed easily. However, for the local LLMs, we do need the big RAM sizes based upon model. Some of these have been mentioned on the screen. Let us now move to the demo. Here we will be downloading a tool to run the local LLM, and we'll run it. For this demo, I am using a laptop with 24 gigabytes RAM and a GPU. I am using a Windows machine. Let's now go to ollama.com and download the Windows version of the installer. So, I have clicked on the Download for Windows option and my download has started. To install Ollama, we will need to follow the same procedure as any other installer. We need to double-click on the software and that will start the installation. This is an easy process and hence we are not covering it in the video. So we were able to install Ollama. Using Ollama, we will be able to run Llama 3 LLM in the laptop. As you can see on the screen, if the LLM is not installed, it will automatically pull the model from the Ollama registry. Start installing the LLM. That is why we are seeing pulling manifest on our screen. This means that Ollama is checking the model registry to find the exact files needed for the model Llama 3. It will store it locally on your machine and then run it. So now we have got the prompt to ask the queries from LLM. Let us ask who are you. We can see the response that I am an AI assistant. So we can see that I am running different queries and LLM is responding to my queries. Now let us see which all LLMs are installed with Ollama on this laptop. For that, we need to run the Ollama list command. We can see that it only has Llama 3. Let us now try to install Mistral on this laptop. Which is also available with Ollama. As Mistral is also installed on this item, let us now check by running the Ollama list command. We can now see that Mistral is also getting listed upon running the command. Now let's see how can we delete the LLM from the laptop. For that, we need to run the Ollama RM command. Once we run the RM command, that model will get removed from the laptop, as can be seen on the screen. Let us now check which LLMs are available with Allama. On the screen is the library of LLMs which are associated with Allama. That's it for this video. Thank you.